In this example, you're asked to graph y equals 1 plus cosecant of 1/2 x. Now, it's always best to start, if you're graphing secant or cosecant, by graphing the reciprocal function. And I'm going to first consider the reciprocal function without the vertical transformation. So instead of the reciprocal of cosecant is sine of 1/2 x. So first we want to get that graph on our paper. And remember that you should always do vertical transformations last. So the plan is to first graph this function, and then we'll change the graph of sine into the graph of cosecant, and we can talk about that. So we'll change it to cosecant. I'll wait till we're ready to do that. And then we'll shift up 1 unit, shift the entire graph up 1 unit. Okay, so starting with that sine graph. All right, I'm thinking about the best way to do this. I guess I'll start this the way I've started all of my other examples, by taking what's inside of the sine function, so in this case 1/2 x, and putting that between 0 and 2 pi. So this will give us the x values that correspond to one complete cycle. Okay, so the only thing I need to do to get x by itself then is to multiply each part of this 3-part inequality by 2. That way that'll cancel the denominator here, and in the middle I'll just have x. Okay, but so that makes these outer values 0 times 2 is still 0. 2 pi times 2 would be 4 pi. Okay, and then I want to make sure I leave myself plenty of room, so let's see here. Put the axes over here. And 1, 2, 3, 4. So I'm going to call this 4 pi right here. Okay, so now to graph that sine function. So you have to remember that basic shape for the sine graph. It looks like this. So it has x-intercepts at that first x value and the last x value. So I'm going to plot those x-intercepts here and here. It's got another x-intercept right in the middle. So if we slice this interval in half, so if it's 4 spaces, when I slice it in half, that'd be 2 spaces. I get another x-intercept. And then I better mark some y values on here real quick. Okay, that's probably enough. All right, so halfway between these first 2 x-intercepts, sine reaches its maximum value of 1. So plot a point right here. And then halfway between those second 2 x-intercepts, it reaches its minimum value, -1. And now I'm going to make this graph dotted since it's not our final answer for this problem. All right, but so there's the sine graph. Now changing this to a secant graph. The first thing is to remember that cosecant, I'm sorry. Remember that cosecant is equal to 1 over sine. So anywhere that sine has a value of 0, you're dividing by 0, the cosecant then is undefined. And so you get these vertical asymptotes. Okay, now, the maximum values and the minimum values in the sine graph are shared with the cosecant graph. So take this maximum value here, and let me make my pen a little thinner since we still have to do the vertical shift up 1 unit. So from here I draw a little parabola opening upward. I'm still making it dotted since we still have to do that vertical shift up 1 unit. And sorry, I'm walking up the stairs while I heard my children coming in. I didn't want them to interrupt this video. Okay. So you've got, I know it's faint because it's not the final answer, but you've got this upward facing parabola here extending from this maximum point, and then a downward facing parabola here extending from this minimum point. The one thing that's left to do is to shift the graph up 1 unit. That's not going to change the vertical asymptotes. The vertical asymptotes are going to stay right where they are. But your parabolas, if I shift this up 1 unit, I get this point here. Let me make this thicker. So here's one part of the graph. Take this point here, shift it up 1 unit, and draw a graph, a parabola opening downward here. And so this thicker graph that I've drawn in red is the final graph for 1 plus cosecant of 1/2 x.